experiment for determination of refractive index of a glass of prism by I versus delta plot. It was found that a ray incident at angle 35 degree suffers deviation of 40 degree and that it emerges at angle of 79 degree. In that case, which of the following is closest to the maximum possible value of refractive index? Now, the situation that is given to us is that incidence angle is 35 degree, emergence angle is 79 degree, and with that the deviation is 40 degree. So if you just take a look at the graph of I versus delta, this is the actual situation represented: incidence angle, emergence angle, and the deviation. Obviously, this is not the minimum deviation. It is deviation occurring for these two separate and distinct value of incidence and emergence. At minimum angle of deviation, incidence and emergence angle will turn out to be same, which is not the obvious case over here. However, the consideration of the problem is quite unique. We require to calculate the closest to the maximum possible value of the refractive index. If we just take the set of the initial data available, then from that we will be able to calculate prism angle I plus E equal to A plus delta. That gives us prism angle as 74 degree. Now from this point onward, the problem takes a quite twist and turn, because nothing as such is available further than this. Apart from that, it is to be understood very clearly that in this problem we are not required to find out any accurate answer to anything. It is simply the quest of finding that what can be the maximum possible value of refractive index from the following set of the given option. So let us say, time being, we assume that 40 degree is minimum deviation, though we know that minimum deviation will not be 40 degree but lesser than 40 degree, as clearly seen from the graph, that minimum deviation would be lesser than 40 degree, not exactly 40 degree, but we have to start with something. So making use of that guess or assumption, we can write formula for refractive index of material of prism as n is equal to sine of incidence angle by sine of emergence angle in the prism, not emergence, actually refraction angle in the prism. So A plus delta minimum by 2 upon sine of A by 2. This is formula that we have. Now in this case, prism angle is known to us, that is 74 degree, and minimum deviation we have assumed to be 40 degree. Again, it is to be made very, very clear that this term, in this term, A is constant value. Delta minimum we have assumed 40 degree, but it is lesser than that. So obviously whatever we are going to get is the refractive index on the larger side, because sine is a decreasing function. If you decrease value of delta minimum, n is going to decrease. So you are taking 40 degree. If the angle of deviation is lesser than 40 degree, obviously n has to decrease. That is a very important information that we must have for solving this problem. Now let us move further and put up this value. So assuming delta minimum is 40 degree, we get n is equal to sine of 57 degree by sine of 37 degree. Again here, some guesswork is required. What we consider, there is practically very small difference between 57 degree and 53 degree, because we know this value of sine 53 degree. So sine 53 degree by sine 37 degree. Sine 53 degree is 4 by 5, 37 degree is 3 by 5. So we get n is equal to 4 by 3. Again, very clear, and again the repetition of the same statement that this is the value of n obtained on the larger side. Obviously n should be lesser than this, because this deviation angle has to be lesser than 40 degree. So we can say that n should be lesser than this value 1.33. That is a very clear indication from the problem what we have solved up till now. Now if you take a look at the set of the options available, it is required for us to find out that what can be the maximum possible value. We know that n has to be lesser than 1.33. So out of all this given option, maximum possible value of refractive index, it can be 1.5, that is option A.